Okay. Now for examples 3 and 4, our job, well, example 3 at least, is to write an explicit rule for each recursive rule. So now that we've learned and done a little bit with the recursive rule and figured out what those are, that's what we're given, and our job is to convert it back into an explicit rule. Okay, so taking a look at number 14. Number 14, first thing we kind of have to look at is the rule, and we've got to look right here at this 3 times a sub n minus 1. So that right there, once you look at it, you start to realize, like, okay, this is geometric because we are multiplying. So kind of thinking back to the geometric, remember, our explicit rule for that basically says a sub n equals, let's see, a sub 1, whoops, not a sub n, a sub 1, sorry about that, times r raised to the n minus 1. So that's our formula that we're following. And now for the most part, like, we have everything that we need, right? We have a sub 1. That's what we're told in this recursive rule. We're told our first term, and that's 4. And then looking at the a sub n part of the recursive rule, we can figure out what that common ratio is. And again, we know that it's a ratio because it's geometric. That common ratio is 3, because we're taking that 3 and we're multiplying it by the previous term to come up with the next term. So actually pretty straightforward. Our explicit rule then is going to be a sub n equals 4 times 3 raised to the n minus 1. So this is really what we're trying to figure out here. Okay? Now, just a little bit of background. Remember, the recursive rule, you basically need previous terms in order to come up with the next terms. But with the explicit rule, you're able to really throw in whatever, or find whatever term you're trying to find. Right now, I would be able to, with this explicit rule, this one that we just found down here, I would be able to find the 135th term if I wanted to, right? I'd just be plugging 135 into the exponent for the n, and then I would be able to find that term. Easy, no problem. But with the recursive rule, we wouldn't be able to do that. We'd have to find the 134th term in order to find the 135th. So that's just something to kind of, that's one of the big differences here. And just to be able to use our skills to go back and forth between the two. So I'm going to quickly go through number 15, because really it's different than 14. So I'm going to do that one, and then I'm going to have you guys pause the video so that you can do number 16 on your own, just get some practice, some reps in with doing this on your own. So now, excuse me, with number 15, again, kind of looking at this piece right here, we have to figure out what type of rule we're dealing with, or what type of function we're dealing with. And you see that a sub n equals a sub n minus 1 plus 11, which means that we're dealing with an arithmetic. Sorry, I know my handwriting isn't great on this. Like I said, I'm still getting used to this. We're dealing with an arithmetic. Now, for the arithmetic, the formula that we have to use, and this was a while ago, so this might not be something that you fully remember talking about, but this is when we were talking about arithmetic sequences and series. We're going to use the formula of a sub 1 plus, and then we're going to do n minus 1 times that common difference. Okay, now a lot of you might remember this as we had to take this common difference and we had to distribute it backwards. So maybe that's ringing a little bit of a bell now. But this is the formula that we're going to end up using. So now, again, we have to use the information that we're given. We've got to find a sub 1, because that's going to have to go for that first part. That's going to have to take place of a sub 1, which is 6 for us. And then finding that common difference, because that's the other piece that's missing. Like, we're fine without knowing n. We can kind of maneuver around that, but we have to know that common difference. And the common difference for us this time is this 11 back here, because it's going up. Remember, with arithmetic, we're looking for that piece that we're always going up by, and that's going to be 11. So now our task is to just kind of take all of the pieces and plug them in where they belong. So we're going to take 6, we're going to plug it in for a sub 1. And then we've got n minus 1. And then we're going to take 11 and we're going to plug that in for d up here. And then we're just going to, our next couple steps here are to take this 11, distribute it through. We're going to have to combine like terms just to get us so that we can have one, one formula, one combined formula. So we've got 6 plus 11n minus 11. So finding those like terms, again, we've got negative 11, we've got positive 6. So our explicit rule is a sub n equals 11n. And then once I combine those like terms, that's minus 5. Okay, and this is, again, this is just kind of the algebraic way of solving it and showing it. But now, you guys, this is in the form of y equals mx plus b again, like I talked about in the first video when we were defining things and looking at them. This is in the form of y equals mx plus b. So we should be able to plug terms in and come out with this, that, and the other thing that we're looking for. Okay, so what I would like for you guys to do, again, pause the video, try number 16. I'm going to do the same thing. I'm going to pause, and then I'm going to come back and show you what I got for number 16. Hopefully that didn't take you very long. So again, here's just my work. It's a geometric because you're multiplying. Again, you're using that formula of a sub n equals a sub 1 times r raised to the n minus 1. And then you guys, you might see this formula or this rule written either way, where you have the negative 1 in there, but you might not have the negative 1 in there. So like this bottom one down here, notice how the 1 isn't in there, they just have the negative. So that's also a possibility that you might see. So if big ideas is rejecting your solution for some reason, try taking the 1 out, and then hopefully that takes care of any issues that you might have. Okay, we're going to take a look at example 4 now. Whoops, I did a little jump there. Okay, so example 4. So the rules before were to, or the directions before were to write a recursive rule for each, write an explicit rule for each recursive rule. So now we're working backwards. Now we're writing a recursive rule for each explicit rule. Okay, so we're given the explicit rule, basically the stuff that we just found on the last slide, and we're going to come up with the recursive rule. Now remember, the recursive rule has us defining what the first term is. So you're probably going to have to figure out that first term in order to come up with your entire recursive rule. So let's figure that out first. A sub 1. So that just requires us to plug 1 in for n. And then, so 6 times 1 just turns into 6. 6 plus 2. So our first term is 8. And then from here, we're going to have to just really quickly, we're just going to have to recall our formula. again, that A, oops, I don't know why that's not working. A sub n equals A sub n minus 1. So this again is one of the first things that we talked about. A sub n minus 1 plus that common difference. So just recalling that formula from, I guess, like the second slide we looked at. So then plugging in just basically the common difference. So your recursive rule should look like this. Define your first term, and then you've got A sub n equals A sub n minus 1 plus that common difference. Ooh, that's the thing that we've got to find now. Common difference here is going to end up being 6, because that's the thing that you are multiplying by. So you're not looking at the back term. You're not looking at what you're adding by each time. You're actually kind of looking at what you're multiplying by. So that's going to be plus 6 back here. And that's going to be your recursive rule. And again, that's just an arithmetic because this is in the form of y equals mx plus b. So that's the arithmetic. I didn't say that before, so apologize for that. Taking a look at number 18 then. Number 18, hopefully you guys are being able to recognize now that this is geometric. So for that geometric, I'm going to do this order just a little differently than I did the last one. I'm going to come up with the formula that we're going to need for this one first. So for this one, you're going to have A sub n equals R times A sub n minus 1. So finding our first term, A sub 1, you're going to have to just plug 1 in up here. Now this is a property of exponents, you guys. If I take 1 minus 1, that exponent's going to turn into 0. So that's going to be negative 3 to the 0 power. Anything to the 0 power is? Okay, hopefully you guys were able to finish that. Anything to the 0 power, remember, is just 1. So A sub 1 is actually just going to be 1 for us. And then from here, A sub n, let's see, that common ratio again, we've got to figure that out. That common ratio is just this base here. So that would be negative 3, and then A to the n minus 1. So this right here is our recursive rule for that next example. So again, I just kind of ask you guys to pause the video, try number 19 on your own. Number 19 and number 17 are very similar, so hopefully you guys are able to get those done, that one done pretty quickly. So I'm going to pause my video, I'm going to show the work, and then we'll come back on and finish it up. Okay, back at ya. So here's my work for number 19. A sub 1, or our first term, I guess, is negative 1. Again, you just get that by plugging 1 into the formula up on top. And then the rest of your recursive rule, A sub n equals A sub n minus 1. And then that's minus 2, because again, you guys, up here, right, that's that common difference that we were looking at. And then hopefully you guys are able to just take a quick look at the, let me just grab a highlighter here really quick. You're able to take a quick look. Notice how this went from a positive to a negative, because that common difference here is a negative 2. So that back there should turn out to be a negative 2. Okay, I'm going to go ahead. I'm going to upload this video, and then I'm going to make the last one. Now, you guys, if you don't have time to look through the last video, that's totally fine. I get it. Some of these are a little long-winded. Bring headphones tomorrow to class if you aren't able to finish them. and then you could just listen to them during class, or you guys ask questions during class. That's kind of the whole point of these flipped classrooms, is for you to be able to come in with whatever questions you have. We can talk about them as a class. So yeah. All right, here we go. I'm gonna upload this one really quick.